Ladies and gentlemen, please welcome Chip Huyen.
So my name is Chip. I'm a machine learning engineer and open source lead at Snorkel AI. It's a startup based in Mountain View, but I'm in Puerto Rico right now. So today I'm gonna talk about career in machine learning. So basically like a little, like in machine learning in general, with a very strong preference to machine learning engineer because I do believe that is the most popular type role in machine learning right now. So a little bit on my background. I think the background is relevant as to show that not everyone has the same path to machine learning. So my background is like the furthest away from tech as possible. So I grew up in this like very tiny village in Vietnam, and then I after high school, in high school, I started writing, and have worked for almost like a decade as a writer. So I'm still writing. So I published some books, and then I switched to become some product. So I was leading an effort to launch Coco browser, which is now the second most popular web browser in Vietnam. So it has about 20 million monthly active users. I was also doing product at Bamui, which got acquired by VNG, which is Vietnam's, I think it's Southeast Asia first unicorn. And then I also do some work at Youth Asia, which acquired by Groupon. And then I went to college and then I started doing machine learning. So I taught TensorFlow, a course on TensorFlow at Stanford. And then I did some research at Primer and Netflix. And then I switched to applied research at NVIDIA, and now I'm fully production. So here a little bit of Snorkel, but we can skip that. So for today, I want to first three major parts. The first is machine learning jobs. And second is some myths about interviewing, and the third is just a very quick about recruiting pipeline. So I think most of this talk, so I think it's strange because I'm not sure if you guys have any question or anything. I guess if you have questions, then please type in the chat. So machine learning jobs. So I think I have a lot of questions about machine learning. So we keep asking me questions like, what is the difference between machine learning engineers and the data scientists, or like what is research versus applied research? So what even is a machine learning engineer doing? So I think for machine learning for research versus applied research is so research is to solve fundamental questions. So you could find so you might so you might develop a new model architecture, and applied research is to make that work for a practical problem. So you can take that like new novel architecture and make it work for on the real world task. So a lot of applied research can be domain specific. For example, you can have like applied research for genomics, for economics, for material science. So for the role, you can have like different roles like researchers and engineers. So researchers is to lead a research initiative, and an engineer should bring engineering skills into realizing that initiative. So a lot of people have been asked. So machine learning engineer role is a very ambiguous role, and if you ask different companies, like different people, companies even have pretty much very different ideas of what machine learning engineer does, or and even within the same organizations, you can ask like two different machine engineers and they can do completely different things. So it's because like machine learning pipeline spans a very wide range of of task, of like I mean like engineering task, and a machine learning engineer, for example, like you have for to develop a machine learning workflow, you can start with a data pipeline. So as in data management, so you need to like collect the data, you like store the data, you need to like deal with like queries, databases. So it's a data like management, and then you go through the next step like creating data set. For so it has like feature engineering, data manipulations, creating labeling, like creating training depth, depth valid test splits, and then you train the models and model selections, so to evaluate the model. If it actually has a model, it has to go and bring it into productions. So you have to deploy the model. So once you have the model, also model in production, there's a lot of things. So you might have to compress a model because maybe too big, it might be too slow. So latency matter a lot in production. So, for example, like you have I will give an example of the task of auto completions in on the iPhone or on the Android phone. So you type something and it suggests to you what you might want to type next. So the speed, like if the speed at which it suggests the next character is slower than the speed at which you type, then that model means nothing. So latency really matters a lot in productions. So but it matters less in training. Because in training you just want to get good models, um, good models and performance model with less of the system metrics. So because of there's so many things to do in bringing machine learning in. Okay, so I'm not even okay. So it's not even done. Sorry, it's just like got distracted because some people were walking downstairs. So after you have the model in productions, you have to monitor it. So I was just reading this very interesting book, like Clean Code by like Uncle Bob. It's a really good book, and he was saying that in software engineering, like 80% of our job is on a maintaining. And I think it's very similar in machine learning. Like you get a model out and it's not done, you will need to like keep on monitor it and see like, if it's doing what it's doing, and if something happens, then what do you do with it? Even if nothing happens, like the models will like degrade in performance. So we need to keep on update the models a lot so that it doesn't go outdated. So because there's so many things in this in the process of bringing machine learning models into productions, that like one person can't do all of it. So for the data pipeline, you might have someone called like a data ops, like people who just work mostly with data and have to do a lot with understand a lot about SQL databases, distributed processing, and map reduce. For the next part, as in like creating data set, like feature engineering, labeling, training model, it might be something called called like machine. Uh, this is what most people know traditionally as machine learning, because it require like a lot of machine learning knowledge. And the next part, like bring a machine learning model into productions, is more of ML ops. So it's a very new field that's growing. So yeah, so a machine learning engineer can be like a lot of things, but you can choose what to focus on. So I think here I kind of made some of the it's very rudimentary, so I think it's still work in progress. Like, so here's a role. You see the role like software engineering, data scientist, machine engineer, researcher, applied researcher, and here on the vertical we have like skill level, and whether you need to be graded, whether you just need a basic level, or is it like something good to have. So for software engineering, you need to know like computer science and like domain specific subject matter expertise. But then for data scientists, you need to know stats and CS, and stats is more important than CS. So data scientists are not engineers. So so you should know a lot about statistics so you can manipulate and get insight from data. But machine learning engineer is an engineer. So you could need to know a lot more computer science than stats. And researcher, you need to stats more CS. And for applied researcher, you need to know like domain expertise and subject matter expertise. So I think like machine learning engineer, so very different from machine learning at startups. So I think a lot of in the work we talk with a lot of companies, and a lot of small companies that come to us is like, hey, we want to do what like like Microsoft or like Google is doing, and I was like, no, you don't want to do that. Like it's very expensive. Like and machine learning research extremely expensive. So and on FastStar is old news by now. Like the field is moving so fast, like everything is just old news after like a year. So on FastStar, like they said, the estimate cost of like on FastStar is like $26 million. And you guys probably have heard about GPT-3 from OpenAI, and I think like the cost to train it once like in like 8-digit. It's like tens of millions of dollars, and it's not to count like the talent cost. Like have a team of like multiple people working, like paying like $500,000 a year each. So like if you have a team of like 20 people, then it's already like $10 million a year just for a team of to train a model like that. So big companies, because it's a big company, so you have a lot of different roles, a lot of different things to do, so they can afford to hire specialists, like people who can do one thing but like really well. For example, like Nvidia can afford to hire someone who's like extremely good at like optimizing one kernel on GPU. But however, a startup, because of because of on the resource constraints, we can't you can't startups can't afford to hire like people who good really good at one thing. Startups like also things move very fast as startup. Like today you think you need to do this XYZ, tomorrow you need to do ABC. So you don't want and people who are very good at one thing can be useful for today, but it might not be very helpful like a week from now on. So startups prefer to hire generalists, people who like know a lot of things and can switch roles very easily. So I can maybe example of me, like I joined a startup like Snorkel. So I joined Snorkel when there were about like 10 people. It's pretty early startup. And in the beginning, I was working purely on engineering. So at first, I was doing machine learning engineer. As in, like I introduced new models into our service into our platform, and then we got problem with scaling because now we had a lot of like big data, other big data set, big like our customers like deal with massive data, and so it was helping with like scaling like more backend. And then at some point, like we need to develop our platforms, and our front end team was so under so much constraints, and I did a little bit of front end, and now I'm switching more to Word because now so we launched in July, which is like 3 months ago, and since then we have been having a lot more interest from the public, from different companies. So we need people to talk with those companies. So I have been switching more and more toward a more outside external facing role. So yeah, so startups like the role can be very fluid, and it can be like a challenge because you have to switch gears all the time. Like I'm not even sure what I'm doing from like as for the company 3 months from now on. But it's so very exciting. As in I feel like I'm learning so much from it. I'm exposed to many problems that I didn't even know existed before. Okay, so move on from this. So another thing is that at big companies, you have a standardized hiring process for the roles because they need to hire a lot of people. So it's a standardized process. They can run it more efficiently. So if you hire first you interview at Google, if we go through like almost everyone who interview at Google for machine engineering role would have like similar, very similar interview process. But as a cost of it is that like it's not very adaptive to different candidates, and you can miss out like on really good people. So startups, you startups like have to make the process as they go, and because they hire less people, they can pay more attention to each individual hire, and also at startups, like one bad hire can bankrupt you. Like at big companies, like if they make a few bad hires, but they make like many more good hires, so it's still okay. But like startups, like for example, a company of 10 people and you make like one bad hires, and it can be very bad for the company. So startups have to pay a lot more attention to every single person they bring on the team. Anyway, and another I keep hearing about is from hiring managers is a difference between junior and senior roles. So for seniors, like you hire them for skills. Like you hire them because they know how to do something, and because senior people like cost so much more. So you want them to hit the ground running and be able to do this. But for junior roles, a lot of people are like straight out of college and don't have much real experience. So people hire junior candidates for the attitude, whether they're willing to learn and whether they can learn quick. A lot of people ask me this question. So these are two of the messages I get from people. I think they sent me a message on, I don't know what it is, it's Twitter. On LinkedIn. So they ask me like, hey, they want to do machine learning, but then I don't have a PhD. What should I do? So you actually don't need a PhD to do machine learning. Like I don't have a PhD, and I know so many great people who just don't have a PhD. And Jeremy Howard from like Fast AI, Alec Radford who did GPT, which is like a pre successor, what predecessor, okay, I'm not a native speaker, I'm sorry. Like with like a previous version of GPT-3, he doesn't have a PhD. I think like Sumit Chintala, the PyTorch creator, also doesn't have a PhD. And also here, I just want to take some examples of people that I think like are great people in machine learning, and they actually they have very different background. Like Christopher Manning, he was one who was helped me teach a course at Stanford. He was a linguist. Christian Payne, she's great. She was a musician. I think she plays for the orchestra. I think, and now she's openly doing research. David Ha, he's really awesome. He is pretty funny because he helped like build the Google Brain office in OpenAI in Tokyo, and he doesn't have a PhD, and he was an investment banker before. So yeah, so there's no one path to ML, and I think like me personally, I did. I was a writer. I'm still a writer, hopefully. Um, so don't yes, there's no such thing as an ML person or non-ML person. So anyone can be a machine learning engineer or a machine learning researcher. So would somebody tell me like when I run out of time? I don't want to keep people like way too long. So the next part is for interviewing myths. A couple of them, a few of them, not a couple. So the first thing is it's like companies love hiring. So you go on LinkedIn and you see companies and there's like we are hiring. Yeah, I think it's funny. So the thing is like companies love growth. Like they love growing. So I think aside like a company hiring is that like they are growing very fast. Like Snorkel right now, we are growing really fast and we're hiring for a lot of people. And the company keep saying, but hiring is actually really stressful for company. So it's very expensive to start with. And so I can tell you like some numbers that I know, like working with some recruiting agencies, like they can charge a flat rate of like 30% to 40% of first year's salary. And if a machine learning engineer like takes like $200,000 a year, then like 30% is already I can't math, like $60,000. It's very costly, and it's not that like in so like engineering time, because like every candidate you bring into the like every candidate you consider, you have to bring them on an on-site. So an on-site is like a 5 hour like a engineering time, like people in the company have to not stopping their work to interview candidates. And it takes like if you bring on 10 candidates for an on-site interview, then it's like 50 hours of engineering like work. So it's more than a week of somebody's work already. So it's very costly like for company. And also stressful for hiring managers. Like if you have a headcount to fill and the work is not being like it's not being done because you don't have people in need, you feel pressure to bring on people. And it's a pretty okay. I don't want to say this, but like it's pretty like it can be very boring for interviewers. It's okay. I keep saying that like for me, like I love interviewing. But sometimes like I think there are days I have like 3 interviews in a day. So like I have to interview 3 candidates. So like I have like 8 hours in a day to work, right? And I really like I just spend 3 hours interviewing people, and it can be like pretty scary. So the second myth is that like companies want the best people. You keep hearing companies saying like, yeah, we want the best and the brightest in our team. This is not true. Companies want the best people who can do a reasonable job within the time and monetary constraints. So say that like there are 2 candidates. Like candidate A can do like 96% of the job and cost like $10,000 and 2 weeks to bring on, right? But then candidate B, who can do like slightly better, like 97% of the job, but it takes them like $60,000 to hire, and then it takes them like 6 months to get on because they have so many responsibility right now. They can't do the job right away. So I'm pretty sure that most company would go with candidate A. So what it means that a lot of like really good candidates can still get rejected just because they don't fit into the time and monetary constraint. The next myth is that company know what they are hiring for. So you would imagine that when a company put up like a job description, just like, oh, we want to hire a machine learning engineer, they know exactly what they're looking for. So it's like it can come. So I talked to like several companies, like a lot of companies, and um, and the thing is like hiring is so stressful and it's so competitive. Like a good so like if you wanted to wait until last minute, like if you want to know for sure that you need that person, it should last minute. Like you are too desperate, and you might end up with somebody like the first person who comes across the door, like who comes through the door. So you might end up with a bad hire just because you're desperate. So companies like start hiring for a role when they are like, maybe we need a person, we maybe they're not. And then we think about the thing about that person, and then we try to think about like what's their money, because they're not even sure if they need that person. So they and a lot of companies, when they hire for machine learning, they don't even already have a very strong in-house machining team, so they don't even know exactly what work is needed. So they might like whip up some very generic job descriptions like, oh, 10 years of experience in like TensorFlow, or like junk like that. Okay, this is a junk like that. Okay, I'm sorry. I'm not supposed to say that. So yes, what I'm saying is like they might come up with very generic description, which is not very reflective of what they actually want a person to do, because they don't know what they want a person to do yet. So the next myth is that recruiters know how to evaluate candidates. So it's very hard. Like I think recruiters are doing those stellar jobs, and I have a lot of my friends are recruiters, and I think they're amazing. But I'm sure that like a lot of recruiters don't come from a technical background. So it's hard for them to get a candidate and they see like, oh, how good that person is technically. So they rely on a lot of weak signals, like previous employees, what degrees they have they got any awards, any papers, have they did any Kaggle competitions, and who refers this person. So that's why companies like so that's why it's so important to like to show these weak signals on the resume to have you pass the recruiter screen. So the next myth is that like interviewers know how to interview. It's pretty funny. So because we're talking to a lot of several big companies, like people interview, and I realized that even big companies have very little or no training for interviewers. So what it means is that like you join a company, you start work for a few weeks, and you shadow a couple interviews, and you go and interview other people yourself, which means that an interviewer might not be very different from candidates. Um, so and last myth, I just want to stress this: that like interview outcomes and no way a reflection of ability or self worth. Like there's so many things that can affect the outcome of interview. It can be like you can be unlucky, like you very good at like ABC, but the interviewers is like good at like DEF. So like choose like interviewer, like you pretty know nothing is that he know or she knows. So you just like it seems incompetent, but it's not. It's just like you just know different things. The interviewer might be in bad mood. You might be in bad mood. Yeah, you might ask a question that you got tripped over. So yes, there's so many things that can affect the interview outcomes. So also companies know that as well. Like it's pretty customary for companies to reach out to candidates like after a year or so after rejecting them. Let's just check it. Hey, do you want to interview us again? Because maybe it's a bit different this time. So I want to like go quickly over the recruiting pipeline. So I think like it's a lot more. It's going. I think like most of the people in this audience are product students, right? So I think I will focus more on the recent grad. So here is like it's a very I think it's pretty interesting graph that I think I did from like like looking through like 14,000 interviews on Glassdoors, and like how interviewees for junior roles are recruited. Also, you can see, for example, like at Uber, about like almost 30% are recruited through referrals. Like over 30% are like on through like online applications. I see at Facebook though, most of them like the highest is like through like a recruiter reach out to them, and the second source is referral, and online application is the third. And if you look at like other like I'm seeing first one like Airbnb, Salesforce. So like referrals like account for a very large chunk of candidates. And I want to see and I want to look at like is it in a different way. So I would say like first of all like 100 of people apply to referrals and 30% of them get interviews, right? So the rate is 30%. But what if like we had like 10,000 people apply online applications and only like 33 of them get interview? So you can see that even like a little bit like even the percentage of people getting online getting to like a job is through online applications. The chance of people getting a job through referral is so much higher than the chance of somebody getting a job through online applications. So that's saying that like yeah, referrals is super important, and so campus recruiting is so super important. So some companies are like very famous for like campus recruiting. It's like Dell, like Cisco is pretty high up. Salesforce is very high. Like Microsoft, like more than Microsoft and Oracle, and more than half of this company like hired through like campus recruiting. So what that means is that like this company goes to like campus career fair, and then try to recruit there, and they can't afford to go to every single campus in the world. So they pretty will focus the effort on a few um, very well known tech engineering school like MIT, Stanford. I think Waterloo is pretty good. It's like it's upcoming. I like it's pretty well known. So it's pretty alarming. Because imagine it's like they rehire from this like popular engineering school, and then the people who from this like popular engineering school refer their friends, and then it become like basically like an Ivy Tech mixer, Ivy Tech mixer. I think there's another interesting thing that I saw, like it's through a Kaggle survey. So most people employed in the field say that they got their job through recruiter, but like most people entering the field are trying to get a job through like company website. So I just want to like I don't want to give that as a discouragement to people to actually like look for job in machine learning. I just want to say that how important referral is, and if you can get a referral. Um, but if you can't, so there's a few things. So first, number one is like it's become really good. So like there's a lot of good books to read. Like online courses, there's so many of them free online. Do competitions, do projects, do internships. And here I just tweeted something yesterday about a list of things that I think I would prioritize learning if I was to study to become a machine engineer again today. So actually, machine learning is actually a very small part of it. And if you want to become machine engineers, then you should first become a very good engineer. And a lot of this, like, are just like Gerald to help you become a better engineer. And second, let me know how good you are. So like GitHub, Kaggle, blogging, YouTube. I got so much out of my blogs. I got a lot of people like reaching out to me after they read my something I wrote about something I did. I like GitHub. I actually hired someone through GitHub because that person's like contributed to an open source project that I was following, and I saw the PR, and it's like, wow, this is really good detailed PR. And I reached out to him and it's like, hey, what are you up to this day? And he was like, oh, I'm actually looking for a job. I was like, oh, that's perfect. Are you interested? So yeah, so yeah, let me know how good you are. Like, don't be afraid to show off your work.